Kia ora, my name's Tane and I'm here today to talk to you about my project on the investigation of subgrade stabilisation in the Bay of Plenty and Waikato region. So a quick overview of this project. I was lucky enough to gain this project through Waerenga Matariki Forest, where I worked with their Tauranga-based office. This study was conducted as it is believed that subgrade strength often leads to an effective road, and the subgrade here being the natural soil layer pictured in this picture here on the right. Now, chemical stabilisation is the option we've chosen to use for this project, this being through lime, polycom, and lime and cement. Now, why stabilise? So stabilisation improves the soil properties. It reduces the quantity or quality of aggregate used. It reduces the maintenance, increases the strength and rigidity, and lowers the overall roading cost. Now, the objective of the study was to investigate the performance of stabilised subgrades, this in terms of strength and costs. So the Stabilisers Trialed, these being polycom, lime, and the lime and cement mixture. So polycom is a granular polymer-based product that binds soil particles together, and this comes in a 2 kg stabiliser, and it stabilises 50 metres cubed, and the 2 kgs comes in a milk-shaped container. With the lime, so lime stabilisation dates back thousands of years, and the lime increases the strength, the workability of the soil, and it creates a relatively impermeable layer. And for this study, the lime was mixed in at a rate of 4%. And then the lime and cement mixture, so the cement was added as it increases the stiffness and strength and stiffness, but has a low impact on the clay soils, is more likely to crack and is less workable. And these factors are often picked up by the lime. So the lime was mixed in at a rate of 4%, and the cement was mixed in at 3%. So to the testing process, so as I said before, there's two forests. There's been Omataroa in the eastern Bay of Plenty and Waerenga in the Waikato region. Sites were selected, so they had similar slope, soil properties, and water drainage. And they were set up, so as you can see here, with site 1, site 2, and site 3 being treated, and then the buffer zone with no treatment on them. Now to the soil classification. This is a big factor influencing the performance of the stabilisers. In Omataroa, it was classified as a yellow/brown pumice or a sandy loam, with high organic content still on the road. In Waerenga, it was classified as a clay loam with grey and reddish/orange clays present. Another factor influencing the performance is the rainfall. As you can see here, in June and July, for both forests, the rainfall was a lot larger than historic averages, especially in Waikato, with June and July being double and triple the historic average. Now to the treatment process. So the first step was obviously to mark out the treatment site, and then the second step here, which is to rip. So this was doing a grade I was used for this, with the rippers set to about 150 mils with the depth, and it was ripped 6 to 8 times just to make sure the soil was well broken up. Second step here was to spread the stabiliser, with the polycom being spread with a electric hand spreader. The lime, as you can see here, was spread with the excavator, and then the cement come in 40 kilo bags, which was hand spread, or the bags were dumped every 1 to 1.5 metres along the 50 metre section. And with the powdered, especially the lime and the lime and cement, a grader had to go through and re-rip, just to make sure that the treatment had been spread correctly. And in tandem with this, the water truck was used. So I would rip and then water, rip, water, and this was repeated 4 to 5 times. The final step included shaping the road with the grader and then rolling it. So to the results, so Omataroa, the polycom increased CBR from 15 to 21, showing a good increase in the soil and environment. However, it did have lower sunshine compared to all the other sites. For the lime, the CBR actually decreased from 23 to 14. I believe this is because of the low clay content in the soil, and also the high organic content, which can be seen in the first image here below, which is about a 20 metre section of really high organic content. And then also the poor compaction after treatment, which you can see in the second photo here through the middle, where 4 tests were done, and they all found really low compaction. So in contrast, the pre-test had good compaction and post didn't. So for the third one here, lime and cement. So already starting off with quite a high base, CBR of 30. It did show improvement, and this is due to, I believe, the high sunshine hours and the higher amounts of gravel and sand present, allowing the cement to form strong bonds. The Waerenga results, so the Polycom showed a huge increase here, increasing the CBR from 9 to 28, and this is probably due to the more sunshine hours compared to Omataroa and possibly the high clay content. For both the other treatments, they showed no improvement. They stayed at CBR of 6 and 8, which is really surprising as the pre-stabilisation tests were done on saturated soil. As you can see in this first photo here with the water actually in the water table, and then the stabilised tests were done on baked soil, which is quite surprising. There's no difference, but you don't know what happened there. But I believe the cement didn't work well in this soil just because of the low sand and gravel content. So to the second part of the objective, the costing. So for the costing, the aggregate, transport, machine hire, and the stabiliser costs were all included, but included and excluded depending on which treatment was used. The aggregate depth was based on a CBR over 30, and this was using the Omataroa's graph. And obviously with the Omataroa's graph, design traffic values were needed, and these were different due to the different road classifications given to the site, with Omataroa being a stub road and Waerenga being a main road. And then different machine hours depending on stabilisers used. So obviously the excavator wasn't used in the polycom treatment, but it was used in the lime, so it was included in the lime calculation. And as you can see in all these graphs here, the stabiliser was more expensive in all cases, with the polycom and Waerenga being the closest. And with it being the closest, I thought break-even analysis would be a good idea. So it was based on these results, and for that it showed a saving an aggregate of 39%. And when this was run for the different depths, it was found that the polycom was going to be cheaper after 420 mils of aggregate required. And then also, if these are based on the values given from Waerenga, but if the aggregate costs were higher, I found I added $15 to the price, and it dropped massively. So the depth was only required to be 300 before the polycom was cheaper. So in summary, the polycom worked better. Worked good on both sides, but worked better in a clay soil with more sunlight, and was easily to apply, but obviously still had soft spots. And if I was going to do it again with polycom, I would trial different mixture rates. In this trial, we mixed it at 80% what was required, so it was a bit less than was recommended by the supplier. But you could go even lower because this showed good results in this trial. And to the lime, it worked poorly in both forests. I don't know why, but this could be due to the application process, the lime concentration, or the weather factors, having a large amount of rain over the curing times. And if it's going to do it next, I'd use a granular or hydrated lime. And into the lime and cement worked well in the Omataroa forest that had high granular soils present. It also had really high CBRs of upwards of 60. Then also had areas that still only had a CBR of 6. So this obviously bring the average to about obviously the middle. Thanks for listening. Any questions?